Okay, 7.4.3. Now we're going to get into some good stuff. We're going to use chords and arcs. And in this one, we're going to talk a little bit about how when you have congruent chords and you try to put them inside a circle, they will create congruent arcs. So I've turned on the rounding. Rounding is to 2 decimal places, I think because it's important here to realize that as I move this around, you can see that the chords, right, segment CB and segment DE, which again are different from arc BC and arc DE. But if I try to hit that perfectly, there we go, 5.21. Now the chords are the same length. And you can see that the central angles on the inside here, right? Central angles are roughly the same, 81.27, okay? And remember again that the measure of an arc is the same as the measure of the central angle attached to it. And so when we do that, I'm getting a little bit shy about erasing things, but in this case, we also have, so we've created 2 congruent segments, which are chords, and therefore, right, the arcs will be the same. And what you have down here is congruent arcs is the same as congruent central angles, which will create congruent chords and congruent segments. And recall, and again, we can do this very, very easily to show what would happen if you have congruent chords, that they will have congruent angles on the inside. And I can do that simply by showing that, remember that if I connect those, and here, and here, and here, those are all radii. They are all congruent. And so we end up having congruent, congruent, congruent all to each other. And if I've already created this side, right, I have the triangles congruent by side, 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 which makes the angles congruent by C, P, C, T, C. If the angles are congruent, then the arcs are congruent. Right? And you can make a backwards argument if you want to. And if, let's say we start with the angles that are congruent. Change this color. If I know that the arcs are congruent, then we have that arc, that central angle is congruent to this central angle. We still have congruent radii. Right? In that case, we would use side angle side to make the 2 triangles congruent, giving the chords to be congruent. Perfect, okay. Another thing just to remember, again, here I have a few things at the bottom. Triangle congruence, postulates, and theorems. So we reviewed SSS and SAS. And also remember that these triangles up here are isosceles triangles, right? And remember that when you deal with isosceles triangles, what's true about the opposite angles? Right, they're congruent. I could hear you. So these angles, let's say, are congruent, and these are congruent as well because you've got isosceles triangles on the inside. Okay, that's 7.4.3. Congruent chords go with congruent arcs.